We'll learn how to find out the roots of a quadratic equation using a C programming. Now, what is a quadratic equation? The equation which is in the form of ax square plus bx plus c is equal to 0. So, here a, b, c are called as the coefficients of this quadratic equation. Now, how to find out the roots of this quadratic equation? So, how many roots will be there? This is the maximum power which is there, that is 2. So, 2 roots will be there for this quadratic equation. What are those roots? So here we can see the formula x equal to minus b plus or minus square root of b square minus 4ac by 2a. So here actually in this formula we have two roots with plus one root and with minus another root. Nothing but r1 is equal to minus b plus square root of b square minus 4ac by 2a, and r2 is equal to minus b minus square root of b square minus 4ac by 2a. So now using this formula, we have to implement the logic in our C program. So now how on what this roots depend on the discriminant. So what is the discriminant here? B square minus 4ac is called as a discriminant. So this discriminant decides the nature of the roots. So now let us see what is nature of these roots here. So if discriminant or d is greater than 0, then root 1 is equal to minus b plus square root of d by 2a, root 2 equal to minus b minus square root of d by 2a. So here what is db square minus 4ac. So what are these? These two roots are distinct and real. So if determinant is greater than 0, roots are real and distinct. Now, if the determinant is equal to 0, if this d is equal to 0, now what happens? If that is 0, only minus b by 2a will be left in this formula. So, both the roots will be equal. So, here what is the nature of the roots? That is equal roots, real and equal roots we get. Now, if determinant is less than 0, then what will be the nature? The roots will be imaginary, because inside the square root we are getting minus. Determinant less than 0 is nothing but some minus value. Within the square root, if we are getting some minus value, then that becomes a imaginary value, right? So now how to find out these roots? Root 1 equal to minus b by 2a plus I into square root of b square minus 4ac, root 2 equal to minus b by 2a minus I into square root of b square minus 4ac by 2a. So here actually here no minus won't be there, square root of b square minus 4ac, that's it, because that minus 1 when it comes out of the square root it becomes a I. Okay, so this is the logic we have to implement in our program. So let us see the program here. So we have included three header files: stdio.h, stdlib.h and math.h. So we will see why we have included all these header files. Now here we have these different variables. A, B, C, D, root 1, root 2, real and imaginary. We will see where we will be using these state variables. So A, B, C, 3 are the coefficients, D is the discriminant, root 1 and root 2, as you know, we have to find out the roots, and this real and image will be used for finding out, for displaying the complex roots or the imaginary roots. We will see. Now, and this program will take the inputs from the user. Those are the coefficients of the quadratic equation A, B and C. So now what is the first condition we have to check? Whether the first coefficient A is equal to 0. If it is equal to 0, then what happens? Then the equation would be quadratic equation. So that is the first condition which should be checked. So if A is equal to 0, then it has to print invalid coefficients and it has to exit from the program. So here we are using exit function. So that's why we have included this stdlib.h. Now we have to find out the discriminant. D equal to B into B minus 4 into A into C. After finding out the discriminant, what we have to do? We have to check for the value of the discriminant, whether it is greater than 0 or equal to 0 or less than 0. So depending on the discriminant's value only, we can find out the nature of the roots, right? So that's why if D is greater than 0, then roots will be real and distinct. Means we get two different roots. So how to find out root 1? Root 1 equal to minus B plus square root of D by 2A. So here square root is a mathematical function which is already available in math.h. So we are using that mathematical function sqrt of D. Similarly, root 2 equal to minus B minus sqrt of D by 2A. Then it will display the roots are real and distinct. The root 1 equal to and root 2 equal to. So these two values it will display on the screen. So now what if D is equal to 0? So if D is equal to 0, then what? Root 1 equal to root 2 equal to minus B by 2A. So here minus B by 2A. Now it will display that the roots are real and equal, and then those two roots are displayed on the screen. Else, so what is the condition left? That is D less than 0. So if D is a negative value. So how to calculate it? See here, you can see in the last case. So root 1 equal to minus B by 2A plus minus B by 2A minus in both the roots. So first part is a real part. So here we are calculating the real part first. So that's why we are using these variables real and imaginary. So real equal to minus B by 2A. So that is here the first part. Now what is the second part? Plus I and minus I, right, respectively. So now after I, what is the value? The values are same. Square root of minus b square by 4ac into 2a. So that is the imaginary part. See here, the same thing we are finding out here. Square root of FABS of D. We don't want the sign here. We have to remove the sign. That's why we are using this ABS function. As the value is floating point value, we have to use FABS of D by 2a. So this is the imaginary part. So after plus I and minus I, this is the value which should be written. Now it will print the roots on the screen. So the roots are complex and imaginary, and then it will format it. It has to format it on the screen. Root 1 equal to percentage F plus I into percentage F. So what should be there in the first part? First part is a real part, right? And then the second part is the imaginary part. So that is the first root. So what is the second root? Second root is again real part minus I into imaginary part. The same thing, it's written here. First one is percentage F, that is a real part, and after minus I, once again we have to display the imaginary part. Okay, so for both the roots, the same values will be used. Real, imaginary, real and imaginary. But only one difference is for the first root, that is plus I, and for the second root, that is a minus I. That's it. That is the difference which you have to observe. Okay. So now we will execute and check for different values. So let us see the different test cases which we have. See here. These are the input parameters. So first we will check with this first case. A equal to 0, B equal to 0 and C is equal to 1. So 3 coefficients it is asking. So 0, 0, 1. Right? So this is invalid coefficients because A is equal to 0. It gives us invalid coefficients. So what is next one? Next one is A equal to 1, B equal to C and C equal to 9. So what it has to give actually with these values, if you calculate on the paper, you get these as real and equal roots. You can try with it. So now we will execute and see 1, 6 and 9. So 1 space, 6 space, 9. See here the roots are real and equal. Those are minus 3 and minus 3. Right? Next. 1, minus 5 and 3. This should give real and distinct. So 1, minus 5 and 3. So now you can see the roots are real and distinct. So next case is roots complex and imaginary. So what values we should give? 1, 4 and 7. So with these inputs we get the complex and imaginary. So 1, 4, 7. Yes, the roots are complex and imaginary. See how it is displaying. First the real part it is displaying, and then plus I and the imaginary part. Here minus I and imaginary part. So I hope everybody understood. Thank you.